Brief Story of Our Universe, narrated and created by Elizabeth Wright. The universe consists of everything, including matter, space, and energy. According to Hubble's law, the universe is expanding, which plays into the current inflationary model of the Big Bang Theory, that the universe came into being quickly and has been expanding outward ever since. Tiny particles, called quarks and gluons, are the building blocks for larger particles such as protons and neutrons, which in turn formed the base for all seen matter. Initially, when the great expansion of our universe happened, everything was extremely hot and dense. But as the universe cooled, it made the right conditions for quarks to be created, which quickly aggregated to produce protons and neutrons, who then formed nuclei. This process only took about 4 seconds. As the universe continued to expand and cool, everything happened much slower. This may sound like this took a long time. Those atoms consisted mainly of helium and hydrogen. To begin with, only took 30 minutes to form from the beginning of the universe. But by about 400,000 years of age, all the heavier elements like carbon, oxygen, and iron were formed and have been continuously produced since by stars' cores. Stars, gas, and dust in space can be polarized in different ways depending on their magnetic fields. The swirls and loops and arcs in this image show the magnetic field structure of our Milky Way galaxy. Clouds of gas and dust that have been disturbed by the gravity of a nearby phenomenon. The disturbances caused clumps to form and draw gas inward. Then it collapses and begins to rotate, flattening into a disk of gas and dust. This disk then rotates faster and faster, pulling more material inward, creating a hot, dense core called a protostar. Polarization of light from cosmic explosions are called gamma-ray bursts. These have been given researchers a look into how magnetic fields are related to those cosmic explosions. These gamma-ray bursts are thought to be formed at the end of a massive star's life. One way massive black holes can be created is through an in-spiral where two massive objects, either black holes or neutron stars, or a mixture of both, circle around each other in a dance of death. They can take eons as they lose energy and get closer until they collide, creating a massive black hole. During this dance and collision, they also create gravitational waves. Currently, it is believed that 4.6 billion years ago, our solar system was created by a solar nebula, a spherical cloud of cold gases and dust. This solar nebula contracted under its own gravitational influence, beginning to rotate and then flatten out into our swirling disk-shaped solar system. As matter, gas, and planetesimals collided in disks, larger bodies took shape, eventually forming planets. They forge their own orbital paths, as seen in this picture. This photo, though, shows Pluto as one of the planets. It was previously demoted to dwarf planet status because its credentials didn't quite hold up to the other 8 planets. We know about how the planets orbit now because of Kepler, who came up with 3 laws of planetary motion. Kepler's first law is that shown here of orbits and ellipses. The Earth was formed several millions of years after the Milky Way galaxy, about 4.6 billion years ago. Our Earth's core is made up of about 85% iron and nickel. The inner core is solid and the outer core is liquid. Then there is the mantle layer made up of lithosphere and asthenosphere. The lithosphere includes the crust and is where most faults and earthquakes occur. The asthenosphere is very close to melting temperatures, much like plastic. The crust layer is only about 1% of the Earth, and 80% of it is made up of igneous rocks. Now that we know a little bit about the universe and our galaxy, let's take a look at the most luminous galaxy we know, that is 12.4 billion light years from Earth. This galaxy is being devoured by an ever-hungry black hole, creating so much energy and momentum that is ripping itself apart. It is likely to end by exploding outward and creating a quasar. Could this be a look into how our galaxy will end as well?